welcome back. Good morning. Good morning. Good to see you all. We're continuing on our study of triangles, and we're continuing with using inequalities. We're going to use inequalities to help us decide if the measurements that we're looking at could in fact belong to a triangle. We can do that because a triangle is formed by three segments, and in order for them to form a triangle, that's a fun sound right outside the door. We're going to ignore it, pretend it's not there. In order for these three segments to form a triangle, so if I handed you straws of certain lengths, they have to be a certain length in order to form a triangle. If I make them too short, you're going to have a gap and you're not going to be able to put them together. Or if I make some of them too long, you're going to have a spiky thing and not a triangle. The triangle inequality theorem is the one that tells us what that relationship has to be. And it says that the sum of the lengths of any two sides of the triangle must be greater than the length of the third side of the triangle. So I'm going to take any two sides, I'm going to add them together, and I'm expecting that whatever I get be bigger than the last side that I didn't add together. So let's practice. We're going to use the triangle inequality theorem to determine if these three measurements, 8 inches, 15 inches, 17 inches, if I handed you a piece of paper that long, if you could actually make it into a triangle without having to do it. So we're going to do 8 plus 15 is 23. Is 23 bigger than 17? Yes, so far so good. Let's do it again, but let's pick two different sides. 8 plus 17 is 25. That means that we're comparing it to the side length of 15. Is that true? Yes, so far so good. We need to do it one more time. We're going to compare the 15 plus 17 to 8. Is 15 plus, what is 15 plus 17? 15 plus 17 is 30, 32, 35 plus 7 is 12, 32. Okay, and that is definitely bigger than 8. So you know what? Yes, this is indeed a triangle. Pretty simple, yes? All right, let's give it a try with one of these. And let's not overthink it. I want to look at number 3 real quick. I'm giving you 3 popsicle sticks and they're all the same measure. Can you make a triangle? Yeah. And we can do this without even doing any of the addition. Why? Because they're all equal, and we have an equilateral triangle whose definition is, hey, all of my sides are equal. And so if I hand you 3 sticks of equal length, you can totally make a triangle out of it. Yeah? All right, that was an easy peasy one. Let's try number 1. All right, so we're going to add the first 2 sides and check to see if it's bigger than the third. 3 plus 4, is that bigger than 6? Yeah. Yes, okay, so far so good. We're going to take the first and the last, and we're going to set it equal to, or excuse me, bigger than the middle. Is 3 plus 6 bigger than 4? Yeah. All right, so far so good. We're going to do 4 plus 6, is that bigger than 3? Yeah. Yes, all right, so this one is also a triangle. Shall we do one more? All right, let's try this number 5 and let's see if this gives us a no. All right, so 4 plus 8, is that bigger than 16? No, 4 plus 8 is 12. 12 is not bigger than 16. So this is a no, not possible. And the directions say explain. So tell me why it's not possible. Because the sum of two sides is smaller than the third. Okay? Because the sum of two sides is smaller than the third side. That's one way to say it. You could say because 16 is not bigger than 16. You could say that too. Because it breaks the triangle inequality theorem. That's another way to say this. All right. Feeling really comfortable with this? Yeah? It's really, really easy, yes? Good. Join me on the top of the next page. The directions state, find the range of measures that the third side has to be in order for this to be a triangle. So find the range of measures of the third side of a triangle given the measures of two of its sides. So I'm going to start with number 7. We know that if I add two of the sides, it has to be bigger than the third side. And so I'm going to write that, but I don't know what the third side is, so I'm going to use a variable as a placeholder for the measure of the third side. So I'm going to take the two sides I already have, add them together, and they need to be bigger than the third side, which I don't know what it is. But now I have an inequality statement that I can solve for. 1 plus 6 is 7. And so 7 needs to be bigger than x. What this tells me is if I hand you bits of string, toothpicks, we'll say, I hand you bits of sticks, one is 1 centimeter big and the other 6 centimeters big, and I tell you, okay, I'll cut the third one for you, how big do you want it? If you tell me 8, then you will not be able to make a triangle with those 3 sticks, because 8 is bigger than 7. Right? And x cannot be bigger than 7. Okay? We're going to do this again, but this time we're going to have the side we don't know be one of the ones we're adding together. And we're going to check to see what values work. Solve this for x. I need to get rid of the 1 from both sides. So I can subtract from both sides, just like I would in a standard equation. And I get that x needs to be bigger than 5. So when I hand you these 2 sticks, one at 1 centimeter, one at 6 centimeters, and I go, how long do you want the third one? You can't tell me anything smaller than 5, because x has to be bigger than 5. So you want something between 5 and 7. Let's check the third combination, see if it gives us anything more useful, narrows it down any further. So I'm going to take the side I don't know and add it to the 6 and say that that needs to be bigger than 1. Again, solving for x, subtract 6 from both sides, and I end up with a statement that says x needs to be bigger than -5. We'll think about that for a second. That means that the stick could be 0 centimeters long. Give me a stick that's 0 centimeters. Okay, I handed you nothing. I did exactly what you want. Would that help? Okay, great question. We did some negative stuff. Are we supposed to flip the sign? The short answer is no. It's when you divide or multiply by a negative. Fantastic question. So this answer really isn't helpful, is it? So I'm going to ignore it. Not helpful. I'm just throwing it away. Not useful. And so I'm going to use these two to help me determine the range that x needs to be, the size that you are going to ask for the other stick to make your triangle. We said that you would ask for a stick that's bigger than 5 centimeters but smaller than 7. And so the way to write that is literally to write the x between those two numbers. X is between 5 and 7, and you write your inequalities going that direction. And so this says x is between 5 and 7. but doesn't include them. It doesn't include them because we don't have the or equal to bar. Okay. Do you want to see it again, or are you feeling okay with this? You're all right? No, you want to see it one more time? Okay, we'll definitely do it another time. The decimal points have me frightened. Can I do number 11? Or do you want to do number 9?
The harder one.
The harder one? Number 9 because of the decimals and oh my god? Okay. Process remains the same. 1.5 plus 5.5 needs to be bigger than my mystery length. So I've handed you sticks, 1.5 feet long, 5.5 feet long. And I go, okay, I have more stick. What size do you want it so you can make a big triangle? And so you're going to do this to tell me what size that you want it. So I'm going to add these together. 7, okay. So 7 is bigger than x. Right now that means that you're not going to ask for a piece of stick that's 7 feet or bigger. Okay? It's going to give you ask for something smaller. All right, let's do the 1.5 foot, this first one. Add it to our mystery length, and it's going to be equal to the second side that greater than the second side I had. Okay, subtracting 1.5 from both sides. X is greater than 4. Okay, so you're definitely going to ask for a stick that's bigger than 4 feet. I suspect the third one is going to be not helpful, just because it feels like there might be a pattern already. But let's run the numbers anyway just to see if it gives us anything helpful. So we're going to take our mystery side, add it to the second measure that we were given, and say that that's bigger than the first measure we were given. Subtract 5.5 from both sides. And x is greater than negative 4. Not helpful. All right, so what's my range? X is between 4 and 7. But does not include them. So I could ask for a stick that's 4 feet and 1/2 inch. It's like, this much bigger than 4 feet. But it's bigger than 4 feet, so it should close. But if I ask for a stick that's exactly 4 feet, it's not going to close. It might just be like this much, like this tiny little bit. Too small, but it'll be too small. All right, we're feeling okay on this? Another example? No? Okay. We've got some proofs. So let's work on proofs. I know. Go ahead and groan now. Oh, God, more proofs. All right, the first proof that I've provided has no reasons. I've given you all the statements, and I'm asking you to justify everything that this person did. So let's start with what we know, what we've been given. I'm sorry? Another copy of this. Thank you. All right, so we were given the two triangles are congruent. All right, we're going to pause there for a second. Two triangles are congruent. What does that tell me? If two triangles are congruent, they're the exact same size, aren't they? Yeah, that means that the sides that match up with each other, the corresponding ones, they're going to be the same size. What about the angles? They're going to be the same size also. So I know that by definition of congruence, that CPCTC thing, that all the different pieces that line up with each other are all going to be congruent to each other. They're all going to have the same measure. Okay, and that's all I know right now. Let's get into the proof and let's see what they're asking for. All right, statement number 1. Triangles are congruent. The reason? Given. Statement number 2. AB plus BC is greater than AC. All right, let me get some colors going so that I can more easily identify what the heck they're talking about. AB is right here, plus BC is right here. So we're talking two sides of a triangle. And then it says it's greater than AC. AC is the third side of the triangle. Two sides added together are bigger than the third side. Where is that familiar from? Ooh, I like where you're going. He said segment addition postulate. Segment addition postulate is when you have it all on a line all together. Since A and B are not on the same line as B and C, we can't use segment addition postulate. But I like where you're going with it. Segment addition postulate also says it's equal to, this is greater than. Yeah, the triangle inequality theorem, the one that we were working with today, where we were adding stuff together and making it greater than. It's this stuff. So this would be the triangle inequality theorem. Let's check to see if the second part of that statement is also true. It says DE. DE is this side of the triangle. Excuse me. EC is this side of the triangle. And CD is this. Oh, yep. Yep. They did the same thing with that triangle. Okay. Next statement. AB is greater than AC minus BC. The triangle inequality theorem doesn't state subtraction, it states addition. AB, AC, BC, that looks a lot like this statement. So how are those two related? How could I go from statement 2 to statement 3?
You just flip them around.
It's almost like a flip, except AC and AB are staying put. It looks like BC is the only one that's moving. We subtracted BC. What's the property that lets us subtract on either side of an inequality? Yeah, the subtraction property of inequality. Is it the same for the second statement in that particular group? Same concept? Okay, good. All right, let's look at statement 4. AB plus DE is greater than AC minus BC plus CD minus EC. Well, I have AB here, and I have AC minus BC here. That looks like it's related to statement 3. And then DE also in statement 3, and CD minus EC also in statement 3. This looks like I added stuff to both sides. What's the property that lets me add stuff? Yeah, this looks like it's a total addition property thing, doesn't it? Now notice that I'm not adding things that are equal to both sides. And it's because this is an inequality. And as long as I'm maintaining the relationship, the fact that on the greater than side I'm adding the biggest of the thing, I should be okay. All right, how did we go from 4 to 5? Well, the left side didn't change. Do you notice that? Left side is still the same? Okay, so the left side is the same. So we just mucked with the right-hand side. But what did we do? BC was here, and now BC is here. We just switched the order they were in, didn't we? Okay. On a test or something, this might be one of the ones that I would just hand you. I can't spell this one. Commutative property. So way back in, I think middle school for you guys, when they were first giving you properties of addition and subtraction. In addition, you could move the order of things and it didn't matter. So notice how we took the sign with it, that subtraction with it. That's allowing us to do that commutative sort of thing. Okay, difference between 5 and 6. Not much, except the parentheses. Pretend for a moment that we're on number 6. What happens if we were to distribute this minus sign? Would we end up back at number 5? Yeah. So this is kind of like we undid distribution. It's still the distribution property, even though it looks like we went backwards. It's still the same property. So this is a total distribution moment. Distribution. And then we suddenly go to equals. AC plus CD equals AD. Okay, let me find AC in my diagram. AC I colored in green plus CD I colored in green equals AD. The whole thing is green. Wait a minute. I took 2 pieces of a longer segment. I found its measure by adding those 2 pieces of it. What was that called again? What did you say earlier? Remember I had said the segmentation function only works if they're all on the same line? And big hint, it gives you is equal to. Is equal to, all on the same line. Do total segment addition. All right, we're going to double check the second thing. I'm just going to color it in to make sure that it's all on the same line. Yep, looks like it is, so we're good. Now, how did we get to 8? Now, we're going to compare 6 to 8 because 7 has a bunch of equal signs and 8 doesn't. And so 6 was our last statement that had the inequalities. Okay, so if I look at 6, and I compare it to 8, bless you, what's the big difference? The A and B is the same. The plus sign's the same. The DE is the same. The inequality is the same. But AD does not appear in line 6. But AD does appear in line 7. In fact, in line 7, AD is the same as AC plus CD. And I see that in line 6. That's suspicious. You're grinning back there. Do you think you've got the punchline? What do you think is the punchline? Okay, well tell me what you were thinking, even if it doesn't sound right. Like midpoint? Okay, midpoint is when you have the point in the middle and it makes the things on either side equal. This might end up being a midpoint, but we don't know for sure. We have to prove that, and that's not what we're after. We're trying to figure out, they use this, the fact that these two things are equal, and they changed from AC plus CD to AD. They replaced it. What's the name of the property that lets me replace things when they're equal? Transitive? Transitive, we need three things all equal to each other. Reflexive is when a thing is equal to itself. But you're right, it's in that same kind of. Symmetric is when you can take it across the equal sign and flip it. Bless you. That's what he just said, symmetric. Side question that'll help answer this one. If I'm out sick or at a meeting, who replaces me?
Substitution.
There you go. We're replacing so we can substitute. I loved how quick you guys jumped on that one. You're like, oh, that's right.
Yes, I was gonna say Richard.
You were going to say Richard? Well, it seems like he's come by very often to take me away, hasn't he? Yeah. All right, let's try number 13. If you guys are watching my social media, I just posted a Snapchat a little while ago, number 14, and said we didn't get a chance to finish this one last class, so stay tuned for the answer. So we're not going to do it in this class, so you have to stay tuned for the answer. So if you're not on my social medias yet, maybe think about it. Okay, anyway. Not trying to get followers, I swear. All right, we're given that H is the centroid of this triangle EDF. What on earth is a centroid?
Center.
You're not wrong, it is a center. It's the point where all the lines meet. Can you be more specific? Do you mean all of the perpendicular bisectors, all of the angle bisectors, all of the medians, or all of the altitudes? Say it louder. Medians. Absolutely right. If you don't remember which one, here's my recommendation. You're in your notes, okay? You're in your notes, and just start flipping through until you see centroid, where three medians intersect. Very nice. You're absolutely right. Okay. So back to here, where medians intersect. Is this dark yellow okay for you to read? It's not too bright? Okay, good. Now, what's a median? Okay, be a little more specific. He said in the middle. We're not quite sure how to form the rest. No problem. Definition of median says that it's going to be a line, and it goes from vertex, which is the corner, to midpoint, which is exactly as you said, in the middle of a line. Look at how many vocabulary words that we had to chain together for that one. We had to know what centroid was. For centroid, we had to know what median was. For median, we had to know what vertex and midpoint were. Should I go ahead and add vertex here? This is corner. Okay, so I'm going to take one of these lines at random so that we can take a closer look at it, and then we'll get into our proof. So let me zoom in here on the figure, and maybe you can see the definitions a little more clearly because I know it was small. All right, so I'm going to look at dx as a median. So the median from D to X, H is the centroid, so it is the point right in the middle. There's H. So D would be my vertex, and X would be my midpoint. X is the midpoint, it's the point right in the middle. What is true now about this segment and this segment? They're congruent, they have equal measure, they are the same size. Yes, yes, and yes. Okay? Let's take a look at the proof. Keep that definition right in the very back of your mind, ready to pounce forward for you. All right, the proof says, statement number 1, H is the centroid of triangle EDF, and the reason is given. And then it says, line segment EY is a median. EY is a median. How do we know that it's a median? Because it has the centroid in it, and all the lines that have the centroid in it are a median, which means you're calling upon the definition of centroid.
Wait, what? Because I don't have a paper. I only have this one.
You only have that one. Okay, let me get you another copy.
This is the
That's okay. I think that maybe the stapler decided to quit. Yes, the stapler quit. There you go.
second.
You're very welcome. Sorry about that. I will take it up with the stapler's boss. All right.
May I go to the bathroom?
Yes. All right, the next reason is we're going to use the definition of median. So we're going to look over here. Definition of median says that it's a line from corner to midpoint. All right. We know that E is a vertex. What kind of point then is Y? Yep. And so this statement can be that Y is the midpoint of line segment DF. The next reason says use the definition of midpoint. All right, definition of midpoint means it's in the middle of the line and the things on either side of it are equal or congruent. We're going to go with equals because I have as my very next step an inequality. That means that I've got some sort of measures I'm dealing with. Which two segments are equal in measure? EF? EX? Okay, you're not wrong looking in here, but you want to look at from Y. DY is equal to YF. Yes. Because that's the other side of Y. Beautiful. The next statement says EY plus DY is greater than DE. Okay, I'm going to use my colors and I'm going to check to see what they're even talking about. EY, I've colored in this kind of gold, so EY. DY I colored in red is greater than DE. I don't have a color for yet, so I have freedom of choice. I'm going to make it highlighter green. Okay. Some sort of triangle. The triangle inequality theorem. I took two sides of the triangle, I added it together, and I said it was bigger than the third missing side. This is a total triangle inequality theorem moment. One more time? Oh, I like that you're looking forward. Number 6 looks exactly like number 5, doesn't it? It really does look. The DE is the same. The EY is the same. It's FY instead of DY. But look at statement number 4. Statement number 4 said that they were equal. They're the same thing. Transitive, you said? Remember, transitive, you need 3 things. I only have 2, dy and yf. Reflexive is when we can say it's equal to itself. What we did was in this one, we had dy, and in this one, we had fy. We made a replacement. We had our Mr. Richards show up again, didn't we? That's all I had for you guys today. Stay tuned to my social medias and I will give you the answer for this 2-column proof, which means this is the challenge for you. Try this on your own. Let it get a little bit messy on you. And then check out my social medias, Twitter or Instagram or Snapchat for the answer. I will post this tomorrow. I'll post it on the weekend. Thank you very much.